All right, so this is factoring polynomials, part 3. In this lesson, we're going to talk about some specific patterns of polynomials that you should be able to recognize as being a bit special. Okay, and the first one we're going to talk about is a perfect square trinomial. Now, just the word perfect square means that all the sides are equal. So in a square, you might have a 1 by 1 square or a 2 by 2 square. And you can extend this example, 3 by 3 square, but in a square, the sides are exactly the same. All right, so let's take a look at this first one here. So in factoring polynomials, you hopefully get to this stage. There's only one way to get x squared, and that's going to be x multiplied by x. And 25 is going to be 25 and 1, or it's going to be 5 and 5. Well, let's do 5 and 5. Now both of these terms are positive, so both of these have to be positive. Now if we check our work here, x multiplied by x is going to be x squared. X times 5 is positive 5x. 5 times x is 5x. And 5 times 5 is 25. Now these two terms add together to give me that 10x that I had originally. Well, let's take a look at this. The first term is a perfect square. Is x squared a perfect square? Yes, it is. The last term is a perfect square. 25 is a perfect square. Yeah, 5 times 5. The middle term is twice the product of the square roots of the first and last terms. Well, what does this mean? Twice the product of the square roots of the first and last terms. Well, the square roots of 1, x squared, are 1, and the square roots of 25 is 5 and 5. So twice the product of those. So 2 times 5 gives me 10. Let's take another look at this example here. What's the square root here? Well, it's going to be m multiplied by m, and this is also a perfect square, 7 times 7. Well, twice the product of the first and last term, so 2 times 7. That gives me 14, which is the middle term. So I know that this is going to be m plus 7, m plus 7. And you can write these. You can write these as x plus 5 squared. Now back to our, and this one you can write as m plus 7 squared. So back to our original example about perfect squares, well, the dimensions of each side are exactly the same. 1 and 1, 2 and 2, 3 and 3. So here, the dimensions are the same. X plus 5, x plus 5, m plus 7, m plus 7. So let's take a look at this one. A squared can only be a multiplied by a. 36 is going to be 6 and 6. Now the middle term is positive, so let's make both of those positive. This one's a little different because we have a negative sign and a positive sign. Well, if you have a negative sign and a positive sign, that means that there has to be a negative somewhere in your factoring. Otherwise, when you multiply, you're not going to get a negative in your outcome. Well, the first term is going to be x times x, and the last one is going to be 10 and 10. Now the question is, how do we get a negative for the middle term and a positive in the last term? Well, if we make both of these negative, when you do your expansion, you'll get x times x is x squared, x times negative 10 is negative 10x, negative 10 times x is negative 10x, and then the negative times the negative will give you that positive 100 that you started with. And when you combine these two, you get your negative 20x. Okay. Well, here we've got both are positive terms. X squared can only be x multiplied by x, and 4 is going to be 2 and 2, and then the two positives, everything has to be positive because there's no negatives in the original polynomial. Here's another one, d squared can only be d and d. 1 is going to be 1 and 1. But we run into the same situation where this is negative and this is positive. So let's make them both negative. That way when we do our expansion, the negative 1 multiplied by negative 1 gets you back to your positive 1. And all of these, before I forget, can be written a plus 6 squared. This one is going to be x minus 10 squared. This one is going to be x plus 2 squared. And this one is going to be d minus 1 squared. So those are perfect square trinomials. So both terms, both sets of brackets are exactly the same. This is another pattern of binomial, and it's called a difference of squares. So what does a difference of squares mean? Well, difference, the word difference means to subtract, and squares, we know what squares are. They're the same thing multiplied by itself. So let's take a look at this first one here, c squared minus 25. So difference of squares, both of these are perfect squares. This is going to be c multiplied by c, and this is 5 multiplied by 5. All right. So let's put those terms in there, c and c, 5 and 5. Now the question is, where does the middle term go? Because in the previous examples we had, 3 terms, x squared plus 4x plus 4, d squared minus 2d plus 1. There's 3 terms. In these ones, there's only 2. So that missing middle term, where does it go? Well, the key here is to make one of these positive and one of these negative. And this is why. When you, oh, my pen is freezing up here.